Hi, third grade. Today we are going to take a look at Unit 3, Relating Multiplication to Division. The purpose of this video is to provide an overview of the standards, intended pacing, and sample instructional strategies. Chapter 1, AKS and IOAs. In this portion of the video, we are going to review the AKS and Indicators of Achievement, or IOAs for Unit 3. The AKS is the overarching knowledge and skills that students are expected to master. The IOAs are the learning objectives that allow students to demonstrate mastery of the AKS. The AKS and IOAs may not be taught in their entirety the first time they appear on the instructional calendar. Some AKS and IOAs will appear multiple times throughout the year. In Chapter 2 of the video, we will look to see how the AKS and IOAs in this unit are paced in detail. Let's take a look at Unit 3, Relating Multiplication to Division. On these slides, you will see the two AKS and IOAs within this unit. Just as a reminder, at the end of each AKS and each IOA, you will see that we have the state coding in parentheses. This is so that if you are looking up resources on the Georgia DOE website, you are able to find the IOA that is related to the GCPS IOA. The majority of our work for Unit 3 is anchored in AKS 3. This unit continues the work with multiplication, with a focus shifting to division. When teaching IOA 3B, our focus will be on the division strategies of repeated subtraction and equal sharing or forming equal groups. We will begin making connections about the relationship between multiplication and division as well. As with multiplication, IOA 3F is embedded within IOA 3B, where the focus will be on solving practical and relevant problems involving division. IOA 3C requires students to apply the properties of operations to multiplication and division. It is embedded within IOA 3D. We explored IOA 3D in Unit 2, and it is further explored here in Unit 3. In Unit 3, students will also learn how to multiply one-digit whole numbers by multiples of 10, ranging from 10 to 90. IOAs 3I, 3J, 3K, and 3L are extensions for Unit 3. These IOAs are here to support the differentiated needs of students. The word extension is bolded and in parentheses to notify you of just that. They are extensions and are specific to Gwinnett County. Remember, you will not find resources from the state of Georgia for these extension IOAs, nor will they be paced on the pacing guide. AKS 5 and IOA 5A will continue to appear in multiple units as it is here. This AKS and IOA requires students to engage in asking and answering questions based on information gathered and/or represented in graphical displays. Chapter 2, Unit Pacing. Our pacing guide is closely aligned with the state pacing. With the first year of new standards, we want to ensure we are following the expectations from the state. As a reminder, the pacing guide is an example intended to model how instruction of the AKS and IOAs in each unit may be facilitated, but teachers should design pacing to be responsive to the learning needs of their students. Now let's take a look at the pacing guide to see how the AKS and IOAs have been paced out over the course of Unit 3. Welcome to Unit 3, Relating Multiplication to Division. In this portion of the pacing guide, we see the name of the unit, the big ideas for the unit, and the suggested pacing. Unit 3 will focus on patterning and algebraic reasoning, along with measurement and data reasoning. The suggested pacing for this unit is 4 weeks. In the next box here, we see the AKS and IOAs discussed in Chapter 1. And below this box, we see the suggested sequence for the IOAs along with the resource column. As a reminder, the left column of the pacing guide will list the learning progression of the AKS and IOAs through concrete, representational, and abstract strategies. The bullets here also indicate the learning objectives for the day as well as suggested manipulatives. The right column here of the pacing guide shows the instructional resources that align to the intended learning objectives for each day of instruction. Some days you will see task-based learning lessons, which is your full numeracy block that day. Other days you may notice instructional resources are linked for the numeracy components of a traditional teacher-led lesson plan. We are starting Unit 3 with IOA 5A. As you dig into these lessons, you will notice that the focus of instruction has shifted to more of a student-driven approach using the statistical reasoning framework to provide a richer, more meaningful experience with data. Students will be exploring different ways to organize data, form a statistical question into categories of their choosing, make decisions about how to represent the data, and then move into generating their own data collection question and gathering data to analyze and interpret. You'll see that both of these days, here and here, are concrete and representational, as students will use either or move fluidly between both learning phases while working on this concept. Here on the pacing guide, we revisit multiplication, where students learn to multiply one-digit numbers by multiples of 10, ranging from 10 to 90. The majority of instructional time will be spent on division. We are suggesting about 8 days of instruction for IOAs 3B and 3F. You will begin at the concrete phase of learning using manipulatives such as counters, color tiles, and snap cubes to model and solve equal sharing division problems, focusing on the equal sharing forming group strategy. Students progress to the representational phase of learning, where they draw equal groups. Students will work through the CRA learning progression while only focusing on the equal sharing problem type. Then instruction will shift to the measurement model of division. Students will use the strategy of repeated subtraction to solve these types of problems. This instruction repeats the same learning progression where students engage in this problem type, beginning with concrete, and then transition to the representational phase of learning, where they draw number lines to represent their repeated subtraction strategies. Lastly, for division, we transition into thinking about how multiplication and division are related. The think multiplication strategy is used to promote the student's understanding of this relationship. Instructional time is also spent revisiting IOA 3D Here, we will revisit the meaning of the equal sign while continuing to make connections to the properties IOA of 3C. The remaining days in this unit are devoted to IOA 3F. Please make note that the last day of IOA 3F, we are revisiting IOA 7C that is connected to area. Specifically on this day, we are finding the missing side link because our students now have an understanding of the relationship between multiplication and division, whereas in Unit 2, our only focus was multiplication. Chapter 3 of the video will highlight specific instructional strategies that will be utilized in this unit. You will see instructional strategies dedicated to multiplication of multiples of 10, division strategies, as well as equivalency among expressions. Please refer to the Analyzing the Standards document or ATS for guidance on additional instructional strategies for each of these IOAs. Hi, third grade teachers. Today we are going to take a look at IOA 3E, anchored in AKS 3. IOA 3E requires students to focus on multiplying single-digit numbers by 10 initially, and then they will progress to multiplying single-digit numbers by multiples of 10, such as 20, 30, 40, etc. When working with this IOA, it's very important for students to understand that multiplying by 10 or multiples of 10 is not the same as adding a 0. This big idea lays the foundation for future work in multiplication in the upper grades when students begin multiplying 2- and 3-digit factors, okay? We are going to talk through that idea, and we are going to do it through this problem. So our problem here is there are 30 boxes of crayons in the art cabinet. Each box has 8 crayons in it. How many crayons are in the art cabinet? As always, when I start with my kids, I always want them to visualize what's happening in this problem, okay? I always ask, what math movie do you see? And if I were modeling this thinking for my kids, I would tell them, well, I see 30 boxes truly stacked inside my teacher's art cabinet, and inside each one of those boxes is 8 crayons. So knowing that I'm dealing with equal groups, and I have 30 of those groups, and they are equal in size because each one has 8, I know I'm multiplying. So I can, and I could also draw my model here, my part whole thinking of 30 boxes and put each in that as well. But I am going to go ahead and write what I do know and have visualized. I have 30 boxes or 30, remember, groups of 8. And what I'm being asked to figure out is how many crayons are in the art cabinet. So I'm just going to put the letter C here to represent the unknown number of crayons, okay? You're going to start using, again, working with this IOA, using the equal group strategy. And as I think about that and the multiplication equation that we have written here, that's a lot of boxes to draw, 30 boxes with 8 in each. So you want to encourage your kids to be efficient in their thinking and use what they know about commutative property, especially when they are solving bigger problems where the groups is actually multiple of 10. That's a lot of boxes to draw or groups to draw. So talk to your kids, tell them you're going to use what you know about the commutative property and use this equation instead. I can flip the factors, and write 8 times 30 equals C. Now, I can go ahead and think through how I can create my equal groups. Okay, so I'm going to walk through today the concrete, representational, and abstract learning phases for you here, and we're going to start with that concrete phase. I'm going to scoop this up out of the way a little bit. Hopefully you can still see my problem. And I'm going to go ahead and model this with my base 10 blocks, and I'm going to build 8 groups of 30. Okay, you definitely want to use your base 10 blocks here so that your students learn to become efficient with their thinking. Truly pulling out 30 counters to go in each one of these groups would be very cumbersome, and you can almost count on there would be some miscounting going on in there. So place value blocks are our tool, and to find the answer here in the beginning, your students are going to use what they know about place value and counting, along with that idea of bundling. So we would go through and count 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. I know 10 tens makes a group of 100. So I'm going to go ahead and bundle that right there. I'm going to go ahead and just start on this side just for efficiency purposes. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Wow, there's 10 more tens, and I know I can group that together because that makes a group of 100. And that leaves me with 4 groups of 10 down here. So to find the total, I have 100, 200, 210, 220, 230, 240. So what I've figured out through my model is that, and I'm going to slide this out of the way, and I know here that we have learned C, the number of crayons, is 240. Okay, just by using my base 10 blocks. As your students transition to that representational stage of thinking, you are going to model the same equal group strategy using base 10 blocks. Instead of building it, I'm just going to draw my 8 equal groups. 1, 2, 3, 4, 5, 6, 7, 8 groups, and in each group I am going to draw 30 base 10 rods. I'm going to draw that here, 10, 20, 30, 10, 20, 30, 10, 20, 30, and continue until each group has the equal amount. Okay, and we know that's 30. When your students have drawn their representation of base 10 blocks, they again will count all and use what they know about bundling. Okay, so we can start that here. Here is 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. I'm going to go ahead and group these 10 rods, and I have just created a group of 100 because 10 tens makes 100. I'm going to continue this. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. I'm going to group these base 10 rods here because I have 10 of them, and 10 tens makes 100. And that leaves me with 10, 20, 30, 40 more. So looking at my model, I have found that we have 100, we have grouped 100, we grouped another 100, we have 40, and I know 100 and 100 is 200, and 40 more is 240. Okay, again, same thinking. All right, we're going to shift to thinking about the abstract level of thinking or learning here with our kids. Students will be presented with sometimes with these problems written as base 10 language, and we're going to talk through that. But they can also use base 10 language to rewrite an equation or an expression if they have to. For example, I'm going to go here to our equation that we used. Thank you to commutative property. And I'm going to rewrite it using base 10 language down here. I want to make sure you can see it. So I have 8 groups of 3 tens. Okay. And when this is written in base 10 language, sometimes it makes the basic fact easier to see. And then students should apply their place value understanding because we are essentially multiplying by 10. So let's talk through what that might sound like when you're modeling this for your kids, okay? I know that 8 times 3, the basic fact itself, is 24. But it's not just 24, it's 24 tens. Oftentimes, students will omit and forget writing tens here, and they end up with just their basic fact, their product for their basic fact, and that's an error in their thinking. It's an error in their understanding that we are multiplying by tens here, and their product should reflect that we are multiplying by 10. So let's say we've gotten here, we know our product is 24, but it's 24 tens. Students can find the value of 24 tens by doing just what we did up here if they need to. They can truly draw their 24 tens out and use their bundling knowledge to group 10 tens to make 100, and then group another make another group of 10 tens to make another group of 100 and count on the remaining, just like we did up here. So let's go back to this, and I'm just going to refer to our answer up here, okay? The answer is 240. I can also write that right here for you, okay? The answer is 240 and not just 24, okay? That is because 240 is 10 times greater than 24. We are not just adding a 0 here, okay? If we did that, and I'm just going to write it down here, if we did add a 0 to 24, because that is what we are saying, when you add a 0, you get 24, okay? This becomes a great misconception as your students progress to the upper grades when they are working with those multi-digit factors, okay? So we are not adding a 0. We are multiplying by tens, okay? As you continuously make those connections for your kids that we are not adding a 0 and we are multiplying by tens and our products should reflect that, a place value chart can be very helpful for students to see what's happening to the product, okay? And I'm going to talk that through for you real quick right here. And they can just draw a place value chart if they need to and label it with hundreds, tens, and ones, okay? So looking at my place value chart, I know that the tens place is 10 times greater than the ones place because 10 times 1 is 10. And I also know that my hundreds place is 10 times greater than the tens place. That's because 10 groups of 10, we rebundle it to make 100. It's 10 times larger, okay? 100 is 10 times larger. So if I write 24 on my place value chart and multiply it by 10, okay? I'm going to multiply it by 10, just like I am going to, the digits actually, the digits will actually shift. The 2 will shift to the hundreds place. The 4 will shift to the tens place because it is 10 times greater than the ones place now, right? And the 2 is 10 times greater than the tens place, which is the 100. And that leaves me with 0 ones, okay? Notice we just didn't add a 0 to the end of the product. Each place value is 10 times greater since I'm multiplying times 10, okay? So again, I am going to reiterate once again that the multiplying by 10 and understanding that the hundreds place is 10 times greater than the tens place. This is a tremendous understanding our students need to gain access to, as it is the foundation of their future work with multiplication when they are digging into multiplying 2-digit factors and 3-digit factors. All right. Don't forget that we have our Analyzing the Standards document for AKS 3, and here you can find more information about this idea of multiplying by multiples of 10, along with more instructional strategies for IOA 3E. Hope this was helpful. Hi, third grade teachers. We are going to jump into looking at IOAs 3B and 3F for this video. IOA 3B is our representing single-digit multiplication and division facts, okay? We did dig into this in Unit 2 along with 3F, that is solving practical and relevant problems involving multiplication and division. The majority of our work in Unit 3 is anchored in both of these IOAs, okay? And specifically, we are really going to make the connection to students explaining and understanding that relationship between multiplication and division, all right? Students learn to represent division facts using the equal sharing, repeated subtraction, and think multiplication strategies. We're going to talk through these ideas using 2 different problems, all right? Let's go ahead and take a look at them right here. My mouse out of the way. Okay, here I'm going to move our IOAs up. There you go. So hopefully you can see our problems. All right. So our first problem here, there are 24 people riding a roller coaster. There are 6 cars on the roller coaster. How many people are in each car? All right, that's our first problem. And our second problem is there are 24 people riding a roller coaster. There are 6 people in each car. How many cars does a roller coaster have? All right, these 2 problems represent the 2 types of division your students will engage in throughout this unit as well as throughout the remainder of the year. The 2 different types of division are our equal sharing or partitive model of division and the measurement or our quotative model of division. All right, so what we're going to do, you can see, we're going to look at both of these problems individually, but before we do that, I want us to make sure and recognize that both of these problems do have the same numbers, but each of these numbers, this 24 people, these 6 cars and these 6 people and the unknowns, what we're being asked to figure out, they have a different meaning. When working with division, it's so important for students to always be making connections to equal groups and how many are in each group, because division is definitely related to multiplication. All right, we're going to focus on our equal group or equal sharing model of division first, and we're going to come back to our measurement or quotative problem in just a minute. All right, so let's take a look at this problem. It says there are 24 people riding a roller coaster. There are 6 cars on the roller coaster. How many people are in each car? Again, always go back to that visualization for your students. What math movie do you see? With multiplication and division, you can continue to anchor your thinking with that part-whole thinking in a bar model. And I'm going to do that here for you. Okay, so if I go back and think about my problem, I know that there is a total, I use a bar to represent my total, of 24 people, okay? That's what we do know. I also know, so we know there are 24 people. I also know there are 6 cars on the roller coaster. That means these 24 people have been put in those 6 cars. So the cars represent my equal groups. I'm going to partition my bar model into 6 equal groups. Let's start with thirds and partition that into 6, into half. So now I have 6 equal groups. 1, 2, 3, 4, 5, 6. Okay. That's what I know. What I don't know are how many are in each of these groups or each of these cars. So I'm going to use a question mark to represent that unknown just in my model here. So by looking at my model, I know I'm dividing. I know I have a total, and guys, division's always anchored in equal groups. Keep reminding your students of that because I promise they will want to subtract. We're dealing with equal groups, but we have a total of 24. We know our number of groups. We just don't know how many are in each group. My 24 total is my divisor. So we have 24 as our total, but it's divided into these 6 cars or 6 groups. And I don't know how many are in each group, how many people. I'm going to use a variable the variable P to represent the number of people. That is our unknown. We don't know how many people are here. Okay. So just to make a connection for you all teachers, what we have done, we have recognized that we knew our total or our dividend is what technically it is called. We know our number of groups here, and this is our divisor. But what we don't know is the size of the group. Okay, that is our quotient. All right, so that's our thinking behind this. And what I'm going to do is walk through this concrete representational abstract learning progression when you are engaging in division problems. Okay, so let's start here. And I know I'm dividing my total among 6 groups. And I can see it in my model and I have it in my equation. So I have here 24 color tiles that I've already counted out. These represent my people, and I know that they are in 6 cars. So I'm going to go ahead and place one person in one car, another person in the second car. There's a person in the third car, the fourth car, the fifth car, and the 6th car. So I have my 6 groups started, and there's one person in each. Your students will equally share these color tiles into each group until there are no more color tiles to be equally distributed. Okay, so I'm going to go here and put there's 2. And another thing your kids will want to do, and we'll make a connection to this in our representational phase, they should count up to make sure they do not go past our total of 24. So we'll go back. We have 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So I have placed my 24 people in my 6 cars. I see 1 group, 2 groups, 3 groups, 4 groups, 5 groups, and 6 groups. In each group, there are 4 people, and I can see that in my model. So the size of my group is 4. There are 4 people. Okay, let's go ahead and jot that down up here. The number of people is 4, right? Let's go ahead and see what it looks like when we draw this out, all right? As you transition to that representational phase of learning, you're going to go back to exactly what we did with our color tiles, but we're going to draw these equal groups, okay? So we know we have a total of 24, and there are 6 groups. We just don't know how many are in each group. So I'm going to draw 6 groups. 1, 2, 3, 4, 5, 6. So I have my 6 groups, and then I'm going to start equally sharing a total of 24 until I reach 24. Okay, so let's go ahead and begin counting, and this is where I made note. Your kids will count up until they get to 24, and that will help them determine the size of the group. So let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. I stop at 24. Okay, I have my 6 groups. Well, now let me look at the size of each group. In each group, I drew 4 tick marks. So this confirms that there are 4 people in each group. All right, so we knew our total, we knew our number of groups, we did not know the size of the group until we equally distributed them. All right, now let's talk about that abstract level of thinking for our students, okay? Here we're going to use the think multiplication strategy. It is very similar to the count up subtraction strategy, but instead of counting up, we are going to multiply up in equal groups, all right? Now, going back to my model, I can clearly make sense of using this strategy because it shows it here, all right? So thinking about my model, I know that there are 1, 2, 3, 4, 5, 6 groups. So I know 6 groups of something. I don't know what that something is going to give me a total of 24. So I can solve division problems using the think multiplication strategy and multiply up. Okay, so this is essentially what I'm solving. And to do that, I am going to, since 6 is my divisor, I am going to count up on the number line by multiples of 6. All right, let's go ahead and do that here. I'm going to always start with 0. And then I'm going to make my first jump of 6, and I get 6. I landed at 6. Another jump of 6 gives me 12. Another jump of 6 is 18. And another jump of 6 is 24. Oh, I'm sorry. Another jump of 6, I was getting ahead of myself, gives me 24. All right. So I captured that counting, that multiplying up thinking on the number line. Okay. Your students may also be at the point where if they want to multiply up, they could just list the multiples. Let me go back to my number line first. Sorry about this. To find the answer, the size of the group, the answer is in our number of jumps. I made 1, 2, 3, 4 jumps of 6. And that tells me there are 4 people in each group. Okay, again, this thinking becomes a lot more abstract than that representational phase does. But back to what I was saying, your students may be to the point also where they can list the multiples. Maybe they just skip count by 6, 12, 18, 24. They always stop when they get to 24, and then they can go back and count how many times they skip counted. I skip counted 4 times, and again, it solidifies and proves that there are 4 people in each car. Hopefully, your students will begin getting to the point when they truly reach that true abstract level of thinking. They will just know what this missing factor is, and just know 6 times 4 is 24. Okay, so we've talked through concrete, representational, and that abstract level of thinking with the equal groups problem. We're going to look at our other problem, and we are going to come back to this and compare both in just a minute. Okay, so let's go ahead and think through this problem. All right, again, there are 24 people riding a roller coaster. There are 6 people in each car. How many cars does the roller coaster have? All right, again, I'm going to go back to that part whole thinking and organize my thinking in a part whole model using a bar diagram. All right, this rectangle is going to represent my 24 total people. All right, I do know that. And I know that there's 6 people in each car. Okay, that's completely different than what we saw in our other problem where there were 6 cars. We already knew our equal groups. Here we don't know our equal groups, but we know the size of each group, meaning there's 6 people in each one of these cars. So I'm going to go ahead and just make a box here because I do know in each car or each group, there are 6 people. I don't know how many other groups there are that I need to partition my rectangle into. That's what we have to figure out. And again, I know I'm working with equal groups. I'm going to divide So my equation would be 24, which is my total or my dividend, divided by the size of our group, the number that we do, the part we do know, that's our divisor, and that's going to give us our unknown, okay, which is the number of cars or the number of groups, right? So what we've done here, we got connecting back to those groups, we know our total, which is our dividend, and we are dividing that into, we are dividing that by the size of our groups, as we knew there were 6 people in each group, and that is going to tell us the number of groups. Okay. All right, so we've got that understanding. We know what's happening in the problem. Now, let's think about what this problem is going to look like when we use our color tiles. All right, I've got my 24 color tiles again right here with me. All right, this time, again, going back, I only know that there are 6 people in each car. Okay, so I am going to make sure, I'm going to go ahead and just get 6 people and put them in a car. Obviously, my color tiles are representing those 6 people. So this is a group that I've created, okay? I am going to repeatedly remove 6 from my 24, continue with this pattern until I get to 0, because when I get to 0, I know all of my people will have been represented. There's 6 more, and that leaves me with 6 people in this car, okay? So we have 6 people in each group. These 6 people make a group, these 6 people make a group, these 6 people make a group, and these 6 people make a group. What I'm noticing is that we have 4 groups, all right? So looking at the number of groups we've created, we know that there are 4 cars, okay? Just that clearly shows that in that model, all right? Now let's think about what that's going to look like from a representational standpoint, okay? Again, going back to what we know in our model, we know we have 24. This time we know 6 people were put in each car. So when I talk about this with my kids, I go back to that math movie. I can physically see 6 people go into this car, 6 people go into this one, 6 people go into that one. So let's go ahead and draw that out. Let's draw 6 people. 1, 2, 3, 4, 5, 6. Those people made a group, okay? Again, I cannot exceed 24, so I'm going to count out 6 more. So I've got 6, 7, 8, 9, 10, 11, 12. That's 6 right there. There's another group. 13, 14, 15, 16, 17, 18. That's another group of 6. 19, 20, 21, 22, 23, 24. Stopping at 24, grouping those 6 people. Again, my representation of what we did with the color tiles looks exactly the same. I have 4 groups. We now know the number of our groups, okay? All right. When you are using the repeated subtraction strategy for the measurement problem types, which is what we did. We repeatedly removed, when we were over here, we repeatedly removed 6 people into each group, right? We did that. We put 6 people here, 6 people here, okay? To keep track of that numerically, students will start with a total of 24. Okay, and I'm going to remove a group of 6, right, from 24. And guys, always go back and rely on those first grade, second grade strategies your students learned. I know I need to get to this 24 to a quick 10. I'm going to decompose this. I know there's a 4, a 2 in that 6. I know when I remove 4 from 24, I get 20, and remove those 2, I get 18. So now I'm going to remove another group of 6. Here, and that's going to give me 12 because I know 6 and 2 makes 8. And then I'm going to remove another group of 6, and I know my doubles, 6 and 6 is 12, so that's my answer 6. And I'm going to put these last 6 in this group, which leaves me with the 0 people. Now here, when your students are working with that repeated subtraction, which is what we did here drawing it, this is just represented numerically, I can clearly see my 4 groups of 6 that I repeatedly removed, okay? We keep coming up with a quotient of 4 every time. Let's go ahead and transition this thinking to that abstract level of thinking. We've talked about these concretely, representationally, and let's think about what this looks like on the abstract level. Going back to our model and what we know, we don't know the size, we don't know the number of groups. So I know some number of groups, some groups of 6 is going to give me a total of 24, okay? So here's what we're going to do. We are going to multiply up. I'm going to start with 0, and I know this factor. I don't know this factor, so I'm going to skip count by 6 or multiply up by 6. I'm going to add a group of 6. I get 6. Add another group of 6. I get 12. And another group of 6. I get 18. And another group of 6. And I get 24. Okay? So our answer is here in the number of jumps, just like it was in our other model. There are 4 jumps on the number line, 4 jumps of 6. The number of cars is 6. Okay, again, hoping your kids eventually move to the part where they just begin knowing 6 times 4 is 24, just like they do with subtraction. Now, let's go back and compare both of these models. Okay, they definitely look a little bit different here, right? Even the bar models that represent that part whole thinking look different. In our equal sharing problem, there's 6 cars. We knew our 6 groups. We could draw those. We just didn't know the size of the group. In our measurement problem, we knew 6 people were in each car. We just didn't know how many cars there were. But we still had the same equation. 24 divided by 6 is going to give you that unknown number. Okay. Again, equal groups, equal sharing problem. We knew the total, the number of groups. We were trying to figure out how many are in each group or the size of the group. And in the measurement type problem, we do our total. We knew the size of the group, how many were in each group. We just didn't know the number. They look totally different. The equal groups we knew, and we equally shared those 24 people among those 6 cars. In the measurement problem, we knew there were 6 in each group, so we drew a group of 6. We drew a group of 6, and we grouped them as we went, okay? Both of these prove that our quotients are 4, but with each problem, again, our models look completely different because of the unknowns. We were either finding the number of equal groups or the size of each group. All right. One thing I do want to point out that eventually at the think multiplication abstract level of thinking, they were multiplying up by 6 each time, and that model does look the same. But as you and your students work with the operation of division, please continue making those connections to equal groups and the size of those equal groups for them. That will help them make that connection going back here to how is division related to multiplication. And we can clearly see here, we can use multiplication or division to solve either one of those problems. All right. All right. So go check out the ATS for more division instructional strategies as you get into this IOA 3B. Hi, third grade teachers. We are going to dig into IOA 3D. We touched on this IOA in Unit 2, along with 3C, our properties IOA. IOA 3D is anchored in determining the equivalency of expressions involving addition, subtraction, and multiplication. It is imperative that students understand the meaning of the equal sign, and this is the main in order to gain access to determining whether or not expressions are equivalent to one another. They need to understand that the equal sign means that this side of an equal sign is the same or has the same value as this side of the equal sign, assuming there were two values on either side. We are going to talk through this problem to get at the heart of what this IOA is asking us to do. Okay, our problem is about Dominic. Dominic's mom bought paint so that he could make a sign. She bought 3 bottles of red paint and blue paint. There are 4 ounces of paint in each bottle. How many ounces of paint did she buy for Dominic? Write an equation with 2 expressions that tells how many ounces of paint were purchased. This problem is asking students to do a couple of things. First, they have to find the total number of ounces of paint purchased, and then they have to write 2 different expressions that tells how many ounces of paint were purchased. All right, so let's kind of think through this problem as I would with my kids initially. As I'm reading this reading this problem and looking back at it again, I know that Dominic's mom, she bought 3 bottles of paint. Okay. I also know that there are 4 ounces in each bottle. All right. Those are the things I do know about this. I am going to organize my thinking for this problem in a part whole model where I'm going to use a bar to represent that thinking. So I am going to go ahead and represent the total amount of paint she purchased, which I don't know yet, I don't think, with this rectangle. What I do know is that she purchased 3 bottles of paint. So that is one part of this problem that I do know. So there's 1 bottle, 2 bottles, and 3 bottles. Again, just partitioning my whole into 3 parts or 3 groups to represent those bottles. In each group, I know there are 4 ounces of paint. So my groups down here represent those bottles. So I can write 4 ounces in this bottle, 4 in this bottle, and 4 more in this bottle. What I don't know is the total amount of paint purchased, and that's what I have to figure out. Okay. Looking at my model, I know I can solve this using not using multiplication. I know that there are 3 groups of 4. Okay, I can clearly solve that using multiplication, and depending on where your students are with their learning with multiplication, some students may choose to build 3 groups of 4, or they may draw it and represent it as draw their 3 equal groups and put 4 in each. Okay. Here I can see that there are 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 4, 8, 12. So I know, first of all, that there are 12 ounces of paint. So I know this unknown here, and I'm just going to use P for my unknown, is 12 ounces. I have 12 ounces of paint. Okay, and P is for paint. I just happened to rewrite it there. Okay, so now we have to think about another expression that is equivalent to 3 times 4. We are going to talk through the concrete representational abstract learning progression for the remaining part of this problem. Okay, we're going to start with the concrete phase of learning, and this is where you will revisit the meaning of the equal sign with your students. To model the meaning of the equal sign, I am going to use a bucket balance here. You have these in your math kits back in your buildings, and we are going to go back to using our concrete model for the expression we initially wrote of 3 times 4, and we learned it was 12 ounces of paint. I am going to take, and our objective here is to determine what expression is equivalent to 3 times 4. Okay, so I'm going to take my 3 equal groups of 4, and I'm going to place them on this side of the bucket balance. 1, 2, 3. There are my 3 groups of 4. It's in here. I know y'all see it. Okay, and so now what we have to think about is, okay, so what do I know about this? What is equivalent to 3 times 4? Hopefully, students will recognize that the repeated addition that you can see here, the repeatedly adding 4 plus 4 plus 4, is the same as 3 times 4. When you're working with your kids, you'll probably want to prove that. Okay, and I'm going to go ahead and just label this side of my bucket balance with the expression of 3 times 4. And over on this side of our bucket balance, I'm going to put 3 groups of 4. And I hope this sticks. Sorry about this, guys. I'm going to add 4 plus 4 plus 4, and we're going to see if it balances. So here is 4 plus 4 more plus 4 more. Help us out. And we can see that 4 plus 4 plus 4 is the same, sorry guys, is the same as 3 times 4. So I have two expressions that are equivalent to one another. They are the same. 3 times 4 has the same value as 4 plus 4 plus 4. Okay, students can write that as, well, I'm just going to jot it real quick right here, and then I will change cameras so that you can see this. So we have learned that 3 times 4 is the same, has the same value as 4 plus 4 plus 4. And we have proved it through the bucket balance because both sides are the same. One side is not tipped in one direction or vice versa. They are equal to one another. Okay, so students will transition to that representational phase of learning from that concrete phase where we just modeled our equivalent expressions using the bucket balance, where they will begin to, they can draw these expressions as well to represent their values. So here for 3 times 4, students would draw 3 groups of 4. Okay, which gives me a total of 12. All right, and it is also the same as, I'm just gonna 1, 2, 3, 4. There's 4 in that group, 4 in this group, and 4 in this group, right? So we know that 4 plus 4 plus 4 is the same as 3 times 4. They both expressions have a value of 12, all right? And if you need to, you can certainly group those because that further confirms 3 groups of 4 is the same as 4 plus 4 plus 4. All right. Okay. So far we have two, we have 2 expressions that are equivalent to each other. But as your kids progress to the abstract level of learning with this IOA, they are going to become more flexible in their thinking, and they will begin to apply those properties, which is why IOA 3C is anchored in IOA 3D. And when they do that, they will begin thinking possibly about 3 times 4 is the same as 3 times 2 plus 2. And here they may have applied the distributive property, or they did apply the distributive property because they decomposed the factor of 4 into 2 plus 2. Okay. And another option some students may come up with, another possible equation they may come up with. For example, if they don't know what 3 times 4 is, okay, but they do know 3 times 5, that's a fact they know is 15, but they also know they need to remove a group of 3 so that they get to the value of 12. 3 times 5 is 15, minus 3 is 12, and 3 times 4 is 12. So 3 times 4 is the same as 3 times 5 minus 3. Again, the meaning of the equal sign is truly vital to understand, and use words as you are going through talking about all kinds of equations with your students so that they become flexible in their thinking, that it doesn't matter, that they know no matter the value on this side of an equal sign and the value on this side of an equal sign, they are the same. Okay, so think about as you engage in number talks with your students throughout the year, make equivalency connections for them. Okay, this will provide background knowledge for them as before you get to teaching this IOA. All right, there is definitely more information in our ATS document for this IOA, so be sure to go check it out. So which strategy? In mathematics, the emphasis is on the reasoning and thinking about the quantities within mathematical contexts. Specific mathematical strategies for teaching and learning are not mandated by the Georgia Department of Education, nor will they be assessed on state or federally mandated tests. Students may solve problems in different ways and have the flexibility to choose a mathematical strategy that allows them to make sense of and strategically solve problems using efficient methods that are most comfortable for and make sense to them. It is critical that teachers and parents remain partners to help each child grow to become a mathematically literate citizen. These standards preserve and affirm local control and flexibility. This is from the Georgia DOE's Comprehensive Grade Level Overview.